Hello students, today we shall perform an activity to verify Pythagoras theorem. First, let us look into what does the Pythagoras theorem state. It states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of other two sides. That is, square of the hypotenuse is equal to sum of the squares on the other two sides. For this, we require some material like cardboard, colored chart papers, ruler, pair of scissors, pair of set squares, compass, pencil and eraser. Now, to begin with, let us construct a right triangle. We consider a right triangle here with sides AB, BC and AC. This is angle A, which is right angle. This is point B and this is C. So, we have a right triangle ABC. Now, to verify our theorem, we need squares on the sides of the triangle ABC. We denote the side opposite to angle A as small a and the side opposite to angle B as small b and the side opposite to angle C as small c. Now, in order to verify our result, we need squares of the sides along BC of length A. So, we construct this square and you can see here that this square is of area A square. Similarly, we construct squares on the sides along AC whose length is B. So, what will be the area? It will be B square. Same way, we have length C here and we need to construct a square of length C. This is our square C whose area is C square. We also prepare cutouts of the length squares of length A. Here this is the square of area A square. This cutout is of square having area C square and here is a square of length B and area B square which is placed along AC. Now, in order to verify our theorem, we need to do some constructions. Look here, first of all we join the diagonals AI in this manner and also we join HB. This is also a diagonal and both the diagonals intersect each other at point O. Now, with the help of set squares, we will construct a line parallel to hypotenuse. Here, we will construct a line RS which is parallel to hypotenuse. This is a hypotenuse BC and in order to draw a line parallel to it, we just slide this set square and this way we can construct a line passing through O. This is a line RS parallel to hypotenuse BC. Now, we also construct a line perpendicular to we construct a line PQ which is perpendicular to line RS in this manner. This way, we see that RS and PQ both intersect at point O. What do you observe? We observe that we obtain 4 quadrilaterals, namely PIRO and ORBQ and BOSA, also OSHP. This way we have prepared cutouts of these quadrilaterals. This is our first quadrilateral. Here comes our second quadrilateral. This is a third quadrilateral, and here comes a fourth quadrilateral. Now, in order to verify our result, we need to arrange these squares, that is square B square, and also these four quadrilaterals on the bigger square, that is BCFG. How do we do that? First, we pick up the cutout with area B square and place it at the center, this way. Now, we will arrange these pieces in this manner, so that they completely overlap the square. This is a third quadrilateral and this is a fourth quadrilateral. Yes, what do you observe? We observe that the squares on the other sides of a right triangle are equal in area to the square described on the hypotenuse. These four quadrilaterals and the square completely overlap a square BCFG, thus verifying our result. The area of the square described on the hypotenuse is equal to the sum of the areas of squares described on other two sides. Thank you.